So today we are going to start with photoelectric effect. First of all, photoelectric effect is reverse process of X-ray production. We have already completed X-rays. What happens in X-rays? We incident a stream of electrons, fast moving electrons. What are those electrons called? Thermal electrons. They are produced due to thermionic emission. Those electrons hit metallic surface and photons are ejected. Those photons come under the category of X-rays. This is what we studied in X-ray. Now here in photoelectric effect, the process is opposite, where there is a metal surface and what are incident on the metal surface? Photons. And electrons are ejected from the metal surface. This is photoelectric effect. First of all, electrons can be ejected from a metal in different ways. Let us briefly discuss those ways. One is thermionic emission, which we already have an idea about. What is thermionic emission? We heat a metal to a certain temperature where the electrons gain the sufficient energy to escape the surface of the metal or to overcome the attractive forces due to the positive charges. These electrons come out of the metal. This is due to high temperatures. This process is called thermionic emission. Then anything else? We have field emission. Electrostatics avutundi kada, you must have heard about this field emission, where you place a metal in extremely large electric field, where the electric field, external electric field, has the capacity to pull out the electrons of the metal surface. This is called field emission. And anything else? We have one more category, secondary emission, where electrons are bombarded onto the metal surface and again electrons are ejected. And very important, last one, photoelectric emission. What is photoelectric emission? Light is incident on a metal. I'll write it here. Photoelectric effect. So in simple words, if you want to write what is photoelectric effect, then what would I write? When light is incident on a metal surface, I can write here, when light is incident on metal surface, after a certain frequency of light, electrons start coming out. This process is called photoelectric effect. And those electrons that come out of the metal surface, when light is incident on it, what do you call those photons? Tell me. When you heat the metal, electrons coming out are thermal electrons. Similarly here, when photons are coming out, what do you call those photons? Tell me. When you heat a metal, the electrons that are coming out, you name them as thermal electrons. Similarly, when light is incident on a metal, the electrons that come out of the metal are called photoelectrons because they are caused due to photons. Okay. And the electrons that are ejected are called photoelectrons. Got it? So have you understood Till here, I have just given you the introduction of photoelectric effect. Yeah, I am standing. Actually, this is a sit-stand desk. I can sit as well as stand. Yes, Nikhil. Most of the metals involved are alkali metals. Let me propose a small experiment. There is a discharge tube like this. And there are two metal plates at two ends of the discharge tube. And these metal plates are powered. They are connected to external EMF. So you can take, this is the EMF. This EMF can be altered. In between, you can place ammeter, voltmeter to measure the voltage and current that is flowing in this wire. Now this side of the plate is connected to positive side, and this side of this plate is connected to the negative side. So you can call this as anode plate. Yes or no? And this is cathode plate. Now photons are incident on this plate. Photons are incident on this plate, and at a certain frequency of photons, electrons start emitting out. Electrons, they start moving here. This is incidence of photons. I'll use a different color. I'll use blue color. This is light. When light is incident on this plate, electrons are ejected, and these electrons are captured by opposite plate. So there is flow of electrons inside the discharge tube, even though there is no medium in between. There is no connecting medium in between. That is how current flows in this circuit. Now tell me, what is the direction of electric field? This plate is connected to the positive terminal of the battery, and this plate is connected to the negative terminal of the battery. So electric field is established in this direction inside the discharge tube. In which direction? Electric field is in this direction. So this electric field is supporting the movement of electrons or opposing the movement of electrons. Can you tell me? The electric field that is established due to the external source is supporting the movement of electrons or opposing the movement of electrons? Opposing, because what is electric field? When you place a positive charge, the positive charge flows along the electric field, but electrons are of negative charge. Okay, so this electric field tries to oppose if connection is like this. If connection is opposite way, if connection is like this is negative and this is positive terminal of the battery, that time electric field is established in opposite direction to that have specified here. In that case, okay, the green confusing on the condition. I'll change the black color. So this is electric field. This is positive and negative. In case of green color, okay, that means you are reversing the polarity of the EMF. That time electric field will be in opposite direction. Electric field will be in opposite direction like this. In that case, electric field will support the movement of electrons. Got it? Now I'll show you a simple simulation of this particular experiment. Through that experiment, we will observe many points. Okay, and after that, we'll list all those points in this slide. Got it? So let me play the simulation, just a second. Are you looking at this screen? Is this screen visible to you? Photoelectric effect, blue color. Okay, let's continue. Sure. First, let us have very low frequency. ఇక్కడ చూపించేది ఫస్ట్ ఎక్స్ప్లెయిన్ చేస్తాను, జాగ్రత్తగా వినండి. Look at this. First of all, here, how is the external EMF connected? This is connected to positive supply. This is connected to the positive terminal. ఇది ammeter గురించి ఎక్కువ పట్టించుకోవద్దు. That will only measure the current flowing in the circuit. So this positive plate, this plate, which is sodium, is connected to positive terminal. Red color ikkada undi kada, positive terminal of the power supply, and this plate is connected to the negative terminal of the power supply. Initially, to keep it simple, let us assume that voltage is 0. Ikkada chudandi, ikkada kinda I can adjust the voltage. What voltage is that? External supply. So power supply is 0 volts. Now this is the plate, okay, and this is the discharge tube. Light is incident onto this plate, okay, and what is the light? What is the frequency of the light here? You can see. Just a second. Idi addostundi. Yeah, frequency is how much? You can see on the top right corner of the screen, 4.49 into 10 to the power 14 hertz. That's the frequency of light, and corresponding wavelength is 668 nanometer. Now this light is incident on the sodium metal. Okay, this metal is positive metal because it is connected to the positive terminal. Okay, this metal is connected to the positive terminal of the battery. Can you see any photons coming out? Can you see any photons coming out here? No. Now let us increase the density. First, look here on the left bottom. I can adjust the photon density. What do you mean by density? That is directly related to the intensity of the light. How intense is the light? Or intensity is directly related to energy incident per time per area. So more intensity and more number of photons, less intensity and less number of photons. So here I have placed intensity equal to 0.01. Now let me slowly increase the photon intensity or photon density, anything is same. So I'm increasing. Increasing. Photon density is maximum. And very high intense light is incident on this sodium metal. Can you see any electrons coming out? Can you see any electrons coming out? That means the ejection of electrons does not depend on intensity of light. This is one point which we have observed from this experiment. Or you can say that the ejection of photoelectrons does not depend on how many photons are incident on this metal. Yeah, I'll share this experiment in the drive, don't worry. Now let me put this in intensity somewhere in middle, 0.5. Now what I do, I start increasing the energy of this light. You can increase energy in two ways. One, by increasing the number of photons. More number of photons and more energy. That is nothing but increasing the intensity of light. Another way of increasing the energy is what? Increasing the energy of each photon and by varying the frequency. Here frequency is 4.49 into 10 to the power 14 hertz. Let me increase the frequency. By increasing the frequency, what happens to the energy of each photon? It increases. More frequency, more energetic is the photon. So I'm increasing the frequency. You see here, ఈ line undi kada, I am moving that line to the right. You can see that frequency is increasing here and correspondingly wavelength is decreasing. That means energy of each photon is increasing. So somewhere you will see the ejection of electrons at some frequency. Increasing. You can see here, the color of this light is also changing because frequency is changing. Color is directly related to frequency of light. Increasing the frequency. You should somewhere here. At 5.49 into 10 to the power 14 hertz, no photon is emitted. Slightly I increase, slightly. At this frequency, around 5.51 into 10 to the power 14 hertz, the electrons started emitting out of the sodium metal. And what do you mean? This much minimum, this much frequency of photons is needed to eject the electrons out of the metal. Now, if you increase the intensity, what will happen? Keep the frequency constant and increase the intensity. Increase the intensity. What can you observe? More number of photons are coming out of the metal. You can see here, more number of photons are coming out of the metal. You decrease the frequency, intensity. You keep the intensity minimum. When you put intensity minimum, still electrons are coming out of the metal. Ante enti? Ejection of electrons depends on the frequency of the light and type of metal. It does not depend on the intensity of light. No matter how small is the intensity of light, if it is having certain frequency, then definitely an electron comes out. An electron is ejected. So ejection of electrons does not depend on frequency. Sorry. Ejection of electrons does not depend on intensity. It depends on frequency. And number of electrons that are emitted, that depends on frequency. As you can see, if you increase the intensity, the number of electrons that are coming out also increase. So number of electrons that are coming out depends on the intensity, but whether an electron comes out or not, that does not depend on intensity. That depends on frequency. Okay. Now let me put the photon density somewhere in between. Now what I do, I increase the intensity further. Now this is the minimum frequency for which the electrons started emitting. This frequency is called threshold frequency. Remember, threshold frequency. Manam increase cheddam. Shanmukh, Krishna will increase the frequency. Don't worry. This is called threshold frequency. Remember, and this wavelength 544 nanometer is called threshold wavelength. This threshold frequency and threshold wavelength depends on type of metal. If you change metal, if you replace this sodium with one more metal, then it will have different threshold frequency and threshold wavelength. Now I'll increase the frequency further. I'm increasing the frequency. You can see what can you see? The electrons are emitted with more speed. Electrons are moving fast. And electrons are having more kinetic energy. Why electrons are having more kinetic energy? Because you're throwing a photon on the metal. Now photon is having certain energy. In that certain energy, some part of the energy is taken to release the electron. It is like toll tax to release the electron out of the metal. What about the remaining energy? That may act as kinetic energy of the electron. So you are giving more energetic photons, and these electrons are coming out with more speed, fast. That means photocurrent is increasing. So as you increase the frequency, photocurrent will increase. Yes. I'm sorry, photocurrent will not increase, but as you increase the frequency, electrons will move faster. But current depends on number of charges moving per unit time. Number of charges depends on intensity. If you increase the intensity, photocurrent will increase. You see here, intensity I'm increasing. Current is also increasing because more intensity ante enti, more photons are incident. More photons are incident ante more electrons are coming out. More electrons ante more charges. More charges flowing ante more current. Got it? You increase frequency to maximum. This is the maximum frequency in this particular experiment. This is the maximum speed of the electrons. Now you can improve the intensity of the photons also. The current is also maximum. Got it? Now, does this current, photocurrent, depend on frequency? We understood that photocurrent depends on intensity. Does it depend on frequency? So keeping the intensity fixed, let us change the frequency. Let us decrease the frequency. You see, photocurrent is same, 16 only, around 16 only. That means photocurrent does not depend on frequency, it depends on intensity. What depends on frequency? Whether the electrons are coming out or not. Got it? Okay. So at this particular frequency, what is that particular frequency? I'll answer all your questions that you're asking in chat once I discuss this experiment. Okay. Frequency is 6.61. And this is the situation. Now what happens? You start applying the external voltage across this discharge tube. Till now, our external voltage is 0. This current is flowing because of photoelectric effect. Now you start applying the voltage. Tell me if this plate is connected to positive terminal of the battery, this plate is connected to the negative terminal of the battery, then the power supply will aid the flow of electrons or oppose the flow of electrons. Tell me, will it aid the flow of electrons or oppose the flow of electrons? Some are telling oppose, some are telling aid. This is connected to positive, and this plate is positive, this plate is negative, and electric field is from left to right, and like this. Electric field is from left to right, but this is a negative charge. Electron is a negative charge. It will have tendency to move in the direction opposite to electric field, not in the direction of electric field. So this power supply is opposing the flow of electrons. So I increase the power supply at this particular, in this particular situation where the photon density is 0.5 and frequency is this much, I start increasing the voltage. I start increasing the voltage. What can you observe? Start increasing the voltage. Current decreases. Current is decreasing because the electric field is opposing the flow of charges. Now, at certain voltage, those charges cannot reach the positive plate. Let us find out that voltage. Let us keep increasing the voltage. You see here, electrons ostunnayi baane undi, but those electrons are unable to reach the opposite plate. You decrease the voltage also. Okay, you can see that 0.46 is the minimum voltage that I can apply across the discharge tube so that the electrons do not reach the other side. What is this voltage called? This potential is called stopping potential. Stopping potential. Stopping potential ante minimum potential that you need to apply across the plates so that the electrons that are incident out of the metal do not reach the other plate. This is called stopping potential. Now, does the stopping potential depend on intensity? Let us check. You increase the intensity. Increasing the intensity. Increase the intensity. Intensity is maximum. Intensity is maximum. But still, no electron is reaching to the other plate. And stopping potential does not depend on intensity of the incident light. Does it depend on frequency? Let us check. What do you think? Does it depend on frequency or not? Stopping potential. You increase the frequency. It should depend, Gada, because what happens if you increase the intensity? More number of electrons come out. What happens if you increase the frequency? Electrons come out with greater speed, greater energy. So this potential may not stop those electrons. Let us see that experimentally. Let us increase the frequency. Student. Electrons are able to reach the other side. And stopping potential depends on frequency. Stopping potential is independent of intensity. Did you understand this experiment? Is it clear? Now let me check your doubts. I know that there is a lot of information that is conveyed to you in a very short amount of time. You go through this video again and again. And also I will share this simulator link to you. You can also use it and get more clarity. Let me go through your questions. Electrons comes out or not depends on frequency. Number of electrons coming out depends upon intensity. Yes, exactly. Very good. But if if frequency is below a certain limit, no matter how much intensity you increase the light, electrons won't come out. Okay, that frequency is called threshold frequency. Next. If voltage is maximum, voltage maximum unte, there is maximum opposition to the electrons. That time, for electrons to reach to the other plate, frequency should be maximum. That time only it can reach to the other plate. What about velocity, inversely proportional or directly proportional? You can say speed of the photoelectrons depend on the frequency. More frequency ankondi, more energy. More energy ante more kinetic energy. More kinetic energy ante more speed. So speed of the photoelectrons depend on frequency. It does not depend on intensity. Next. What is that red color essence on the wire? Ida, and generally red color denotes positive terminal and black color denotes negative terminal. Even in your AC circuits also, meantlo wires chuste, red color is a live wire and black color is what is that, neutral wire. Next. Yeah, I'll make you write all these points. Don't worry. We have only discussed. We'll make a note of all the observations. Sriram Satvik is asking, due to stopping potential, electrons can't reach to the other plate. What happens to those electrons? They'll be wondering. And they do not go into the metal surface because they already are rejected, but they cannot reach the other side also. They'll be wandering here and there. Once increase voltage to the maximum. Okay. And a maximum electric field. These electrons cannot reach. Now let us increase the frequency also to maximum. You can see that even when the frequency in this particular experiment is maximum, electrons are not capable of reaching the other metal because stopping potential is very high in this particular experiment. Okay, Satvik raised your hand. Okay, just a minute. Chepu.
Sir, I was asking about this thing, sir, not the red color on the voltmeter. This red color essence which is present on the wire, why it is coming when we increase the voltage, sir? Is it some kind of resistance, sir?
No. I think if you increase the voltage, current carrying capacity of the wire will increase. So the wire becomes more thick, and a more thicker wire is required.
Okay.
ఇంట్లో కూడా మీరు ఏసీ వైర్స్ చూస్తే అవి కొంచెం లావుగా ఉంటాయి, మామూలు రెగ్యులర్ వైర్స్ చూస్తే సన్నగా ఉంటాయి. ఎందుకు? ఏసీ వైర్ మోర్ వోల్టేజ్ అంటే ది కరెంట్ క్యారింగ్ కెపాసిటీ ఆఫ్ ది వైర్ షుడ్ బి మోర్, సో ఇట్ షుడ్ బి మోర్ థిక్. అదే అనుకుంటున్నాను నేను, అయి ఉండొచ్చు అవ్వకపోవచ్చు.
Okay, sir.
Yeah, because of stopping potential, current production will be hindered. Correct. Increase the intensity also to maximum. Yeah. Before increasing the intensity to maximum, what do you think? If I increase the intensity to maximum here, do you think those electrons will reach the other side? What do you think? It should not, because number of electrons will increase. ఎక్కువ ఎలక్ట్రాన్స్ వస్తాయి బయటికి, అంతేగాని అవి ఏమి అవతల సైడ్కి పోవు. So let us check that also. You see, more electrons are coming out, but still current is zero because the electrons are unable to reach to the other side. Next. Sir, in case of any other metal, will the electron reach in this situation? Yes, definitely. There is something called as work function of the metal that I'll explain in theory. Okay, that tells you how much energy is required for the electron to come out. If that work function is less, then electron will come out with more energy. Okay, so definitely whether the electron will reach the other metal or not depends on this metal also. If you replace that sodium with any other metal, maybe electrons can reach the other side. What is the minimum stopping potential? Stopping potential antene minimum. There is nothing called minimum stopping potential. Stopping potential ante minimum potential that you need to apply so that the electrons will not reach to the other side. Got it? Next. Sir, what if we take a metalloid and there will be wandering electrons in that case? See, electrons should be easily ejected. That is only possible in case of metals, because in metals, electrons are loosely bound. If you replace metal with some non-metal or metalloid, then electrons may not come out that easily. Okay, and we perform all these experiments with metals only, not non-metals or any metalloids. Got it? Okay, so let me stop this simulation. Let us go back. ఈ లింక్ నేను పేస్ట్ చేస్తాను. Ctrl+C. Control. Photoelectric effect simulation. Okay. సరే, ఈ ఈ పర్టికులర్ స్లైడ్ లో ఉన్నదంతా నోట్ డౌన్ చేసుకోండి, దెన్ ఐ విల్ గో టు ది నెక్స్ట్ స్లైడ్. మేక్ ఇట్ ఫాస్ట్.